Hello students, today we're going to learn section 8.1, the Pythagorean theorem and its converse. The Pythagorean theorem states that if you have a long side of a triangle, square it equaling the leg of the triangle plus another leg of the triangle squared each, then you have the Pythagorean theorem. So in this case, C is the hypotenuse, A is a leg, B is a leg. So if c squared equals a squared plus b squared, then you have a right triangle. A Pythagorean triple are three side lengths of a triangle that represents a right triangle. More importantly, the three side lengths are positive integers. In order to have a Pythagorean triple, all the side lengths have to be positive integers. So 3, 4, 5 is a Pythagorean triple. If you put 5 as hypotenuse, that's 5 squared equals 4 squared plus 3 squared. You will get 25 on both sides. And the same holds true for these other Pythagorean triples. So again, identify the hypotenuse. Hypotenuse is always the longest side, so 5 is the hypotenuse, 13 is the hypotenuse, 17 is the hypotenuse, and 25 is the hypotenuse. And we checked, and these are Pythagorean triples. So 5 squared equals 3 squared plus 4 squared, 25 equals 25. 17 squared equals 8 squared plus 15 squared, 289 equals 289. That's why it's important to identify the longest side so you know what to use for your hypotenuse. 6, 8, 10, and any multiples of these triples are considered Pythagorean triples. Alright, it says here, example 1, a right triangle has legs of length 16 and 30. Find the length of the hypotenuse. Do the lengths of the sides form a Pythagorean triple? Well, this is a leg, so we're going to take 16 squared plus 30 squared equals c squared. So c is our hypotenuse, leg, leg. Simplify, we have c squared equals 1156. Take the square root of 1156. You will get plus or minus 34. Now again, we're only going to keep the positive because in order for us to use the Pythagorean theorem, we're going to use positive numbers to have a Pythagorean triple. We don't use the negative answer because when we talk about lengths of a triangle or lengths of anything, lengths are always measured in positive units, not negative. Alright, so now we know that 16, 30, and 34 is a Pythagorean triple. If you wanted to find another Pythagorean triple, divide everything by 2 and you get positive integers. Therefore 8, 15, and 17 are Pythagorean triples. Alright, so example 2, it says find the value of x, leave your answer in simplest radical form. So that means do not use a decimal. Alright, so now let's take a look at this. They want us to find x. You notice this is our hypotenuse because the hypotenuse is always opposite the right angle. So this is your hypotenuse, leg, leg. So 12 squared equals x squared plus 10 squared. Square the 12 and the 10. Simplify, subtract 100 from both sides. Now you have plus or minus the square root of 44 equals x. When you simplify that, this is what you end up having. So 44 is the same thing as 4 times 11. The reason why I like this these factors of 44 is because one of the factors is a square number. So the square root of 4 is 2. So now your simple radical form answer is 2 squared 11. The reason why we can't simplify this anymore is there are no other square factors in 11 other than 1. So the final answer is going to be 2 square root of 11. Again, we do not include the negative because we're dealing with distance of a triangle. Example 3. A baseball diamond is a square with 90 feet sides. Home plate and second base are at opposite vertices of the square. About how far is home plate from second base? Okay, so let's work out the problem here. Here's first, second, third. There's home plate. We said that 90 feet, and we said that the baseball diamond is a square. So to find the distance from second base to home plate, we're going to use the Pythagorean theorem. The reason is we actually have a right triangle. Here is the right angle, here's the hypotenuse, leg, leg. So that's why we can use the Pythagorean theorem. X is our hypotenuse, leg squared, leg squared. So now we square 90, we get 2 times 8100. To undo the square, you take the square root on both sides. So when you take the square root on both sides, x equals plus or minus 2 times 8100. 8100 is a square. So the square root of 8100 is 90. So the square root of 8100 is 90. So x equals 90 radical 2. And it should be x equals 90 radical 2 feet. Alright, so the distance from home to second base is 90 square root of 2 feet. Next topic, we have theorem 8.2, converse of the Pythagorean theorem. They're stating that if the longest side of a triangle squared is equal to a side squared plus another side squared, if these two values are equal to each other, you will have a right triangle. Alright? So therefore ABC is a right triangle. Okay, in example 4, is a triangle a right triangle? Well, we can check that. Alright, so before we could put a right angle, let's check this. The longest side is 7, so I'm going to make that our C, our A, and our B. Always look for the longest side first to determine what C could possibly be. So when we substitute it into the Pythagorean theorem, we have 7 squared equals 4 squared plus 6 squared. Calculate everything. 49 equals 52. That is a false statement. Therefore, the triangle is not a right triangle because the left side does not equal the right side. Okay, so that is example 4. Theorem 8.3 states if the longest side squared is greater than the sum of the two sides squared, then the triangle is obtuse. So again, if the longest side is greater than the sum of the two sides squared, then the triangle is obtuse. Theorem 8.4. If the longest side squared is less than the side squared plus a side squared, then the triangle is acute. Again, remember, if they're equal to each other, then we have a right triangle. So you're going to have 3 options for this example. It could be a right triangle, it could be obtuse triangle when this side squared is greater than the two sides squared added together, or it could be an acute triangle if the longest side squared is less than the sum of the side squareds. So example 5, they want us to classify each triangle acute, obtuse, or right. So the numbers represent the lengths of the sides of a triangle. So first determine what is the longest side. Well, the longest side there is 25, so I'm going to make that the hypotenuse. So when we make that the hypotenuse, it's 25 squared equals 15 squared plus 20 squared. So we have 625, 225 plus 400. 225 plus 400 is 625. 625 equals 625. Therefore, this is a right triangle because both sides equal each other. All right, let's go back to this example here. When we notice that the longest side squared is less than this value, we know that this triangle, this would be an acute triangle. So again, this would be an acute triangle because the longest side squared is less than the sum of the two squared sides. So this, again, acute, because 49 is less than 52. This one, we have 25 squared equals 15 squared plus 20 squared. They equal each other, then it's a right triangle. Looking back at the other problem here, part B, we have 10, 15, and 20. So again, determine what the longest side is. It's 20. So we're going to put that as our C. So when we put it in, we have 20 squared. We don't know if it's equal, less than, or greater than. 15 squared plus 10 squared. 400, 225 plus 100. 400 is greater than 325. Therefore, this is an obtuse triangle because the C squared, the longest side, was greater than the A squared and the B squared. All right, that's it.